Hello students, welcome back. Let us continue with chapter 9 of your textbooks. We will continue with exercise 9.3, question number 6. Now it's been given that in quadrilateral ABCD, diagonals AC and BD intersect at point O such that OB is equal to OD, and it's also been given that AB is equal to CD. We need to prove three things. The first thing that we need to prove is that area of triangle DOC is equal to area of triangle ACB. So, where are the triangles DOC and AOB? We need to prove that the areas of these two triangles are equal. Then area of DCB is equal to area of ACB. So, DCB and ACB, and we also finally need to prove that DA is parallel to CB or ABCD is a parallelogram. And the hint has been given that from D and B draw perpendiculars to AC. So, let us go ahead and draw these perpendiculars. So, I will say let DM and BN be perpendiculars to AC. So, how will we prove the first thing, that area of triangle DOC is equal to area of triangle AOB? We will have to split these triangles. So, first I am going to prove these two triangles congruent to each other, 1 and 2. So, which are the triangles? DOM and BON. How are these two triangles congruent? See, these are a pair of vertical. Let us draw these triangles. I have D, M, O, then O, B and N. Here I have right angles. These are a pair of vertically opposite angles, and it's also been given that OB is equal to OD. Therefore, what can I say? That the two triangles are congruent to each other by the AAS test of congruence. See, you have angle, angle, side, angle, angle, side. Therefore, the two triangles are congruent by AAS test of congruence. Therefore, the area of these two triangles are equal. Similarly, now once you prove that these two triangles are congruent, you can prove that DM is equal to BN once by corresponding pair of congruent triangles. So, let us just prove this first, then we will go ahead with proving the next section. So, I will say proof. First, I will have to write the construction. Draw DM and BN perpendicular to AC such that C, M, O, N and A. This means that all these vertices C, M, O and A, they lie on the single line CA or AC. Now, let us go ahead and prove the first section. Now, in triangle DOM and triangle BON, what do I have? OD is equal to OB, it is given. Then angle DOM is equal to angle BON. Why? Because they are a pair of vertically opposite angles. And finally, I have angle DMO is equal to angle BNO. Why? Each is 90 degrees. Why 90 degrees? Because we have drawn DM and BN perpendicular to AC. Therefore, what do I get? Therefore, triangle DOM is congruent to triangle BON by AAS test of congruence. Therefore, area of DOM, area of triangle DOM is equal to area of triangle BON, because we know that for two congruent figures the areas are always equal. This is what I will mark this as 1. Okay. Now, using this, what can I say? Also, DM is equal to BN. Why? Corresponding pair of congruent triangles. Let's mark this as 2. Now what I'm going to do is I'm going to prove the other two triangles congruent. Then I'm going to add the triangles to get triangles DOC and AOB. So what will I add to DOM to get DOC? I will add DMC. And what will I add to BON to get AOB? I will add BNA. So I need to prove that these two triangles out here now. So which are my triangles? This 3 and 4. I will prove that the area of these two triangles are equal. So first I need to prove that these two triangles are congruent to each other. Let's draw these triangles for our reference. So I have DMC and I have ABN. We just proved that DM is equal to BN, right? These two are equal. Also, it's been given that DC is equal to AB. This is already given, right? And this is a right angle. Therefore, through right angle hypotenuse test, what can I say? That these two triangles are congruent to each other by RHS test of congruence. So once you prove that these two triangles are congruent, you can say that the areas of these two triangles are equal. You will add these to this and prove the first section out here. So let's go ahead and prove the two triangles congruent first. Now in triangle, so triangle DMC and triangle BNA, I have DC is equal to AB, DC is equal to BA. This is given, right? Also I have DM is equal to BN, and in fact for DC and BA I am going to say hypotenuse, just 2 seconds, hypotenuse DC is equal to hypotenuse BA, right? Then I am going to say DM is equal to BN from 2 and angle DMC is equal to angle BNA because each is 90 degrees. Therefore, what can I say? Therefore, triangle DMC is congruent to triangle BNA by RHS test of congruence. Let's mark this as 3. Now let's add 1 and 3. When you add equals to equals, the wholes are equal. So we will add the right hand side of this with this and the right hand side of this with this. So I'll say adding 1 and 3, what do we get? That area of triangle DOM plus area of triangle DMC is equal to area of triangle BON plus area of triangle BNA. Correct? So DOM plus DMC, see DOM plus DMC is going to give you your triangle DOC. Therefore, area of triangle DOC similarly is equal to area of your triangle AOB, because triangle AOB, because when you add these two triangles out here, BON and BNA, you get your triangle AOB. So this is the first section, it's proved. I'll erase this because we do not need it anymore, but make sure you have drawn these for reference purpose while proving. Okay. Now what I need to prove, that area of triangle DCB is equal to area of triangle ACB. So let's locate DCB and ACB. Where do I have DCB? I have, so let me erase this 1, 2, 3 and 4 that I have marked. Now DCB and ACB. How will you prove that these two triangles are, the areas of these two triangles are equal to each other? See, we have proved that area of these two triangles are equal, right? Obviously, if I add OCB to each of these triangles, what will I get? I will get exactly this, DCB is equal to ACB. Okay, so let's write this down. And let's mark this as equation number 4. I will say area of triangle DOC is equal to area of triangle AOB, and I will say from 4. So which triangle do I need to add to these triangles? I need to add COB. Adding triangle or area of triangle COB on both sides. What do we get? That area of triangle DOC plus area of triangle COB is equal to area of triangle AOB plus area of triangle COB. This will give you what you need to prove, that is area of triangle DCB. Area of triangle DCB is equal to area of triangle ACB. Let's mark this as 5. Let's confirm DOC and COB. See, DOC and COB is giving me DCB. Similarly, AOB and COB is giving me ACB. Therefore, the areas of two triangles are equal to each other. Now, the third section. I need to prove that DA is parallel to CB. So, now if you notice, these two triangles that we just proved, the areas that we proved equal to each other. If you notice, DCB and ACB, DBC and ACB, they lie on the same base CB and they are equal in area. Therefore, what can I say? That the two triangles lie between the same parallels. Therefore, which are my parallels now? CB is parallel to DA. Therefore, now CB is parallel to DA is parallel to CB, and also it's been given that and we also need to, or we have to prove that ABCD is a parallelogram. So, let's just write this, then we will see for the parallelogram. Now, triangle DCB and triangle ACB lie on the same base. So, which is your same base? BC and are equal in area. Therefore, triangle DCB and triangle ACB lie between common parallels. So, which are my common parallels? DA and CB. Therefore, what can I say? That DA is parallel to CB. So, now I have proved that DA is parallel to CB. I also need to prove, see here it is an OR, but it is always good to prove whatever is required. So, I need to prove that ABCD is a parallelogram. Now, if you notice that OD is equal to OB, this is given, and also we proved that these two triangles are congruent to each other. Where did we prove this? DOM and this was the first part that we proved, DOC and AOB. They are congruent to each other. Therefore, what can I say? That OA is equal to OC. So, if you notice, the diagonals are getting bisected at point O. So, what do we know for a parallelogram? That the diagonals bisect each other. Since for quadrilateral ABCD, diagonals AC and BD are getting bisected at O, I can say that ABCD is a parallelogram. So, let's write this down. Now, triangle DOC is congruent to triangle AOB. I'll say from 1, right? Therefore, I have OA is equal to OC, right? And Y, I will say corresponding pair of congruent triangles. And also I have been given that OD is equal to OB. This is given. So I am erasing this section. Therefore, diagonals AC and BD are getting bisected at O. Why? Through this. OA is equal to OC and OD is equal to OB, which means that diagonals AC and BD are getting bisected at O. Bisected at O. Therefore, I can say that quadrilateral ABCD is a parallelogram. Hence proved. So we have proved all the 3 sections. So please take a look that ABCD is a parallelogram. So we have proved that DA is parallel to CB for my 3rd section and ABCD is a parallelogram. And what did we use here? That triangle DOC is congruent to triangle AOB. We have taken it from this point. This is point number 4 and not point number 1. And OA is equal to OC, OD is equal to OB. See, OA is equal to OC, OD is equal to OB. So the diagonals are getting bisected at O. Hence, the quadrilateral ABCD is a parallelogram. And using this, we have solved question number 6. Thank you for watching the video. We will continue with the rest of the questions in the next videos.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.